You've probably heard this before. Light is both a wave and a particle. People say it like it's a clever compromise, like nature couldn't make up its mind, so it picked both. And at first, that feels reassuring, flexible, sophisticated, almost wise. But I want you to notice something uncomfortable. The moment you say both, you stop asking what light actually is. You feel like the mystery has been handled, filed away, and that's where the real trouble starts, because waves are things, particles are things. They come from a world where objects have shapes, paths, and locations you can point to. Light doesn't live in that world. The wave or particle story sounds like understanding, but it takes really a pause button for your curiosity. It lets your intuition rest when it should be screaming. Here is the unsettling part. If light were truly a wave or truly a particle, physics would be much simpler than it is. Comfortably wrong, but simple. Instead, every careful experiment forces us into a corner where neither picture survives. And once you see that clearly, there's no gentle way back. So let's do something simple. Not theoretical, not abstract. Imagine a dark room, a wall, and in that wall, two very thin slits cut side by side. Behind the wall is a screen. You turn on a light source and let it shine toward the slits. Nothing dramatic yet. You've seen this in textbooks, animations, maybe even a lab demo. You already think you know what's coming. Bright bands, dark bands, interference. Now slow it down. Turn the light down until it sees almost nothing. So dim that Fawton's individual hits arrive one at a time. Click. A tiny flash on the screen. Click. Another flash somewhere else. At first it looks random, no pattern. Just lonely dots appearing one by one, like rain hitting a roof. If you stopped here, you'd be confident. This is a particle, you'd say. Little bullets flying through space, hitting the screen wherever they land. That feels good, solid, familiar, but don't stop. Let the experiment run. Minutes pass. Slowly, quietly, something disturbing begins to emerge. Those random dots start forming a pattern. Not because they talk to each other, not because they arrive together. Each photon arrives alone. Each one hits one spot. And yet, taken together, they build the same interference pattern you'd expect from a wave. Now pause. Ask yourself, really ask yourself what just happened. Each photon landed at a single point. That feels particle-like. But the pattern they collectively form only makes sense if something interfered with itself. So what interfered? Did each photon split? Did it go through both slits? Did it somehow know whether the other slit was open? Try to picture it. Really try. This is the moment where intuition starts to slip. Because every picture you reach for tiny ball, spreading ripple, ghostly smear breaks the instant you push it too far. Now make it worse. Put a detector at one slit, just to check, just to see which slit the photon goes through. The pattern disappears. Nothing else changes, same light. Same slits, same screen. Only the question changed, and suddenly, the universe gives you a different answer. That's the trap. Once you're inside it, there's no classical way out. At this point, most explanations panic. They reach for familiar tools, hoping one of them still works. Maybe the photon carries extra energy. Maybe it spreads out and then snaps back together. Maybe it makes a decision at the last moment. But notice what all these ideas have in common. They're trying to rescue a picture. Energy is supposed to flow like a substance. Objects are supposed to have paths. Events are supposed to happen somewhere in a definite order. So we test that instinct. If light were really a particle, then each photon should choose a slit, one or the other. And nothing that happens at the unused slit should matter. But it does. Close one slit and the pattern changes. Open it again and the pattern returns. So the photon must, in some sense, be aware of both slits. That already feels wrong. Fine, then maybe it's a wave. A wave spreads out. A wave goes through both slits. A wave interferes with itself. But waves don't arrive as single, indivisible clicks. They don't hit a screen in isolated points and politely stop. So we try to compromise. We say the photon is sort of a wave, until it's measured. Then it becomes sort of a particle, but that explanation quietly smuggles in a miracle. When exactly does the change happen? At the slit, at the detector, at the moment someone looks. The moment you ask that, the story collapses. There is no place to put the switch without inventing new physics on the spot. This is the low point. Every classical idea fails, not gradually but decisively, not because we lack imagination, because imagination itself is the wrong tool here. You're not missing a better picture. There is no picture to rescue. So if pictures fail, we stop drawing pictures. Not because reality vanished, but because the kind of reality we're used to is no longer available. Instead of asking what the photon is, we ask a quieter question. What can we actually calculate? And strange, that question has an answer. We don't track objects. We don't track waves. We track possibilities. For every way the photon could go from the source to the screen, we assign a number. not a probability, something more delicate. This number carries two pieces of information: how strong the possibility is and how it lines up with other possibilities. You don't add probabilities yet, that comes later. First, you add these possibility numbers together. That's the key move. If two possibilities line up, they reinforce each other. If they oppose each other, they cancel. Nothing mystical, just arithmetic. Now notice what happened. We never said the photon went anywhere. We never said it split. We never said it chose. We only kept track of what could happen. When both slits are open, there are multiple possible ways for the photon to arrive at a point on the screen. Those possibilities combine. Sometimes they add. Sometimes they erase each other. That's where the pattern comes from. Not from a wave in space, from interference between possibilities. And when you place a detector at one slit, you remove possibilities. You force the situation into fewer allowed stories. Now the remaining possibilities can no longer interfere the same way. The pattern disappears not because the photon changed, but because the bookkeeping changed. This feels abstract, but stay with it. Because something remarkable happens if you commit to this way of thinking. You stop asking where the photon really was. That question no longer makes sense. Instead, you ask what the rules allow and what they forbid, and the rules are brutally consistent. They don't care about comfort. They don't care about intuition. They only care that when you square the final combined number, the probabilities match reality. That's it. No hidden mechanism, no switching behavior, no secret wave turning into a particle, just rules for combining possibilities. Now here is the moment that usually breaks people. This method works everywhere, not just for light, for electrons, for atoms, for molecules. Anything that remains isolated enough follows the same logic, the same bookkeeping, the same interference, the same refusal to behave like a thing. So the idea of wave-like behavior stops being special. It's just what happens when multiple possibilities coexist. And epiparticle-like behavior, that's just how results appear when you finally look. One outcome, one click, one point on the screen. The world doesn't smear. Your knowledge does. This is the midpoint where the story tightens. Because now we can say something precise and unsettling. The photon never travels as a wave. The photon never travels as a particle. Travel is the wrong verb. Between emission and detection, there is no story made of objects and paths. There is only a structured set of possibilities evolving according to rigid rules. And the rules are not negotiable. You can't peek without changing them. You can't ask which way without destroying interference. You can't demand a picture without breaking the description. This isn't philosophy. It's restraint. Physics learned the hard way to stop asking questions it cannot define. And in return, it gained a framework that predicts experiments with terrifying accuracy. That's the trade. You give up imagery. You gain inevitability. And once you accept that, the old question, is light a wave or a particle, doesn't feel deep anymore. It feels misplaced. Like asking which direction north points in a world where direction itself is the wrong concept. At this point, it might sound like we've drifted away from reality, possibilities, bookkeeping, numbers that interfere. It feels almost too abstract to be trusted. So here's the uncomfortable check. This isn't a philosophical framework. It's the reason your phone knows where you are. The GPS satellites above you don't rely on pictures of particles moving along neat paths. They rely on timing that must be calculated with extreme precision. Signals travel at the speed of light, and the only way to predict when those signals arrive is to use the same rules we've been talking about. Not wave stories, not particle stories, just calculations that treat light as something governed by strict non-classical rules. If engineers tried to simplify this back into intuition, the system would fail in minutes, your location would drift, navigation would collapse. So this isn't optional weirdness. The universe does not care whether the explanation feels satisfying. It only cares whether the numbers come out right, and they do. Once you accept this, the feeling changes. It's no longer about light being strange. It's about the universe being stricter than you expected, not driven by forces pushing things around, but by constraints that quietly forbid certain stories from ever happening. Light doesn't decide how to behave. It doesn't negotiate. It obeys rules that leave no room for alternatives. What feels mysterious isn't randomness. It's discipline. The rules allow interference, so interference appears. The rules forbid knowing which path, so that knowledge never survives. Nothing dramatic happens behind the scenes. No hidden machinery clicks into place. Reality simply refuses to give answers to questions that don't fit its structure. And that's the unsettling shift. We're used to thinking the universe does things, but here the universe mostly says no. No to trajectories. No to pictures. No to classical explanations that once felt obvious. What remains isn't chaos. It's a world that works perfectly, just not in the way our intuition expects. So the next time you see light from a screen, a street lamp, or the sun, remember this. What reaches your eyes is not a wave rolling through space, not a particle flying on a path. It's the final answer to a question you were never allowed to ask directly. Between emission and detection, the universe did not tell a story you could picture. It followed rules instead. And the strange part isn't it that light refuses to make sense. It's that it works at all, without ever asking for your intuition's permission.